my new Solaris synthesizer at NAMM 2009. And I'm just going to give you a quick tour of some of the ideas that are in this synthesizer. What I started out was doing a lot of analog synths way in the old days, right? And as things developed, I've seen more and more, synthesizers control go down to signal displays with lots of levels of menus and stuff. So after having done a few years of software synthesizer design and seeing the power of a software synth with all of the parameters you can have, but not having the accessibility like I'd like, I basically put this idea together to have multiple screens, put out the basic groups of sound that we use to make synthesizers, like oscillators, LFOs, filters, and amps, and put those at an easily adjustable layout with the 6 displays. It's an emulative software synth done in hardware. It has different emulations of analog things, of digital things, so let's take a listen. First, I'll start out with some Mini Moog emulation sounds. And this is using both the Mini Moog oscillator and filter emulation. And now here's something using a wavetable sound. And let me call up a sample sound. Here's just a simple sample of a marimba, but we can also take that sample and we can modulate it from any audio oscillator. And here it is being modulated by a sine wave. Same marimba sample, but now be modulated. Everything can modulate anything else, and you can route any audio signal as you like. We take a look over here on the oscillator types really quick. There are 4 oscillators, and we've got a multi-mode oscillator with a variety of standard wave shapes. We've got a wavetable oscillators, a Prophet 5 or Curtis Electro Music oscillator type, sample playback or wave files, Prophet VS wave shapes, and a Mini Moog oscillator type. So, and the plan is as we can grow, as we develop more oscillator types, we can just load those in via USB. Likewise, on the filter, we have the same idea, filter type. This is a multi-mode type with low pass, high pass, band pass. There's 23 variations here. And then we also move to a solid-state music emulation, Mini Moog emulation, Oberheim, and a comb filter. So we have many different varieties of things, but again, we can expand it as needed. And there are 4 filters in parallel. There's actually 4 about everything. 4 oscillators, 4 mixers, 4 insert effects, 4 filters, and 4 VCAs. On the VCA, by the way, we do have some alternate emulations. There's a logarithmic, linear log, or sigma, which is a more typical of a Mini Moog type curve on the VCA. So trying to just incorporate all of these different elements to make something new. Now there is something unique to this instrument called a rotor. It's something like a 4-step wave sequence. It plays 1, 2, 3, 4. We're listening to, here's 4 oscillators playing. They're all triangle waves, but they're all tuned a little bit differently. As you can see here, +7, +19, +24. And if I want to slow that down, and if I want to do crossfading, so you get that kind of sound. But you can also run them at audio rates, and now it's scanning the 4 inputs so rapidly that it becomes its own tone, which is set by the tuning here. And if I change any of the inputs, let's change the tuning of this guy. What basically does it affects the harmonic timbre of the output. So that's called the rotor. And then one other thing I'd like to show you, there's recursive control. You can feedback anything into itself. In this case, I'm taking a Mini Moog sound, which sounds like this without the feedback, but here's filter 1 coming back into the mixer, and as I turn it up, you hear that's obviously a lot thicker and more organic sounding. So what we're trying to do here is take the advantages of the digital technology. There's over 850 parameters, and trying to make that accessible and usable to present something to the sound designers out there and the synthesizer guys that really want to have a new tool to express some new ideas with.